So hello everyone, we are here for solving the problem of the day. Today we have got height of the binary tree. Let's read the question. Well, very simply it just says that we have to find the height of a given binary tree. Okay, if we see the function parameters, you are receiving the root of the whole tree, and then what we have to do, we have to return an integer signifying the height of this tree, right? So if we see two examples here. Okay, so for this tree, we are given height to be true, height to be 2, right? Why is it so? Because as you can see, the longest distance is either 1 or 2 or 1 or 3, right? Because these are two same distances, and the number of nodes lying in it is 2. So the height is going to be 2 for this one. If we have to define height, we can say that height is the number of nodes present in the longest path from the root till any of the leaf nodes. Okay, so we only had two choices here, and from both the choices we were getting two as the answer. So 2 is returned here. On the other hand, if we see this tree, so the height that this tree has is 3. Why? Because as you can see, this is the only and the longest path of our tree, beginning from the root, then we go to 1 and then we go to 3, correct? So the height becomes 3 because we have 3 nodes in this path, in the longest path. To understand it more clearly, let's try to solve it ourselves. All right, here are the same examples. So how are we actually calculating it? We know that if I say height, we mean number of nodes in the longest path. From root to root till any leaf node. Fine. So here, how many leaf nodes do we have? We have 2 leaf nodes, right? From this, we know that height is 2. From this, we know that height is 2, right? We have to always choose the largest one. Okay, so we could have had one more node here. Then how would the answer modify? Then we have to say that this is the longest path, and how many nodes are here in this path? We have 3 nodes, correct? Then the answer would change to 3. But till these nodes, those are green, that means which are already given as a tree. In the sample case, what is the answer? Answer is 2. Let's talk about this tree. Okay, so we simply know this is the longest path, and how many nodes does it contain? It contains 3 nodes, right? If I modify the tree a little, if I say one node was lying here, then will the answer change? It won't, correct? Because although this is one more path till your leaf, still this path has height 2, correct? And this path has height 3. So what, we have 2 heights. Now what are we going to say when we are asked about the height of the whole tree? Well, the height of the whole tree is the greatest one. So 3 is the greatest of these both. So it is going to be the answer. Okay. Yeah. It might have a little ambiguity right now as well. So let's understand it with a bigger tree. Okay, assume this is the structure of a tree that you are given. What logic you are going to apply? Now we understand that what is height, okay? But what logic is behind getting that height? Well, we have to think it recursively. Okay, we have to think it recursively. And in recursion, what is the basic thought process? That we have to break down a problem into smaller chunks, and then we have to do only one step. Okay, we have to do the calculation, do the work in only one step. Okay, and rest is taken care by the recursion. So if I have to break down this problem, if I have to again break down this problem into smaller problems, how can I do that? Well, in case of trees, generally binary trees, what do? We expect something from the left subtree, and we expect something from the right subtree, and we perform the calculation for this step. That means that where we are standing right now, and the answer is given back. Okay, this is the basic recursive thought process that is used in most of the tree questions. Okay, now let's see what logic we can use in the similar pattern for finding out height. So what if I say, if I get the height of this subtree and I get the height of this subtree, I can just add up 1 to that height because I'm standing at this node, right? Whatsoever height I get from here or whatsoever height I get from here, I just have to add 1 to it. And that 1 is for including this node where I'm standing right now. Okay, so whatsoever height it will give, it is going to be something. Whatsoever height it will give, it is going to be something, which has to be considered. I have just shown you in this example, you can see we were receiving 2 answers. We were receiving 2 from here and 3 from here. Which one was being considered? The greater one, right? Here we are going to do the same thing. This subtree will return some answer. This subtree will return some answer. We have to consider the bigger of the both. Okay, whatsoever is bigger of these both, we are going to consider that, and we'll add 1 to it, assuming A is going to be bigger. So I'll add 1 to it and I'll return that as my final answer. Okay, now what is actually happening inside this? Because in recursion, you call function inside a function. So when you are having root, you called this. You called the recursive function for this height, and you call the recursive function for this height. We have to calculate, see, the primary problem was we have to calculate the height. Now I have to calculate the height of left subtree and the right subtree. Let's go to the left subtree first. When we call the same function, the function that is helping us to find height in this left subtree, what will happen? Again, this will be dealt as a completely whole new tree. Fine. For the next function, this will be a whole new tree. Again, what will happen? Again, what will happen? We are going to be here, and this is going to be the new considered root for us. It also has 2 subtrees, the left one and the right one. It is going to go to its right, correct? Again, this will be the root. It will also go to its right and it will go to its left. In this case, it is null, correct? Once we reach this point, okay, once we reach this point that we have no further nodes to go, or let's say we are here at this node and we call the functions again, and we call the function again, but the functions will be encountering null, correct? And null means this is the base case. Whenever we hit null, that means it is at 0 height, because we cannot include null as a node, right? So it is going to return 0. Once 0 come here from the left side, I'm just talking about this particular node, okay? For this node, we call the recursive function for left subtree and right subtree. Left subtree returned the base case, which is 0. Right subtree returned the base case, which is 0. And what is the condition that we were following? We were picking out the bigger value. Okay, it is going to be 0, right? What we have to do next? We have to add 1, including our own height. We have to add 1. And then once this is done, we have our first answer. What is the answer? We know that this particular node has the height of 1, and it is true if we see it like this. If we see this as a separate tree, we know that the height is 1, correct? So the answer of this node is done. This node will return the answer to the previous node. It will say that my height is 1. Now it is up to this node. It is also going to make a call to its right. Well, this time it is null. And what happens when it is null? It returns 0, correct? And now this node has to make a choice between 1 and 0. Which one is bigger? Obviously 1 is bigger, so 1 will be kept here. Okay, not 1 will be kept here. 1 plus 1, because we have to include the height of this node as well. Thus the final answer till this subtree is going to be 2. So let me clear it up. Okay. Now till here, we know that the answer is 2, right? Now I'm going to go to return my answer to this node. This node was waiting for its left subtree's answer. Now it has its left subtree's answer. Other thing it is going to do is it is going to make the same call on the right subtree. The right will happen. The same thing will happen here. We will deal this tree as separate new tree. It will make 2 calls to here, to here. And once it makes this call, what will happen? It will return 0, it will return 1, it will have 1, correct? It will return, the call will be going here, then here. It is going to be getting 0 from here. And let's say this is at the height of 1. We already know that. We have done it here. It is going to return 1. It is going to return 2. At this point, at this level, we have again 2 choices, 1 and 2. What choice we are going to make? we will pick up 2, add 1 to it, include this node, and then finally we will be returning 3 here, right? Finally we'll be returning 3. So what is the current scenario for this node? This node is receiving 2 from one side and 3 from the other. Which is going to be considered? The bigger one. 3 will be considered, plus 1 will be added to it, then answer will be returned as 4. Okay, so now this is the first call of the recursive function, which I made from the root itself. So now I have one answer. I have 4 as the answer of my left subtree. Okay, we have traveled the whole tree. We have received the answer as 4. The same thing is going to be happening here in the right subtree. It will be calculated in the very similar fashion. We will hit this node, and this is the base node, right? And this 2, this will be returning 1, this will be returning 1, correct? This is actually just counting, nothing else. At this point it will become 2, at this point it will become 3, correct? And 3 will be the final answer for this subtree, and 3 will be returned, correct? Now at this point, what do we have to do? We have to compare two values. What are those two values? 4 and 3. Which is going to be considered? 4 is going to be considered. Why? Because it is bigger. Correct? Now what will happen? Finally, I'll just add 1 to my 4 and I will return the final answer, which is 5. Right? So I hope now you have understood the dry run of this problem. Let's try to write some code for it. Okay? What is going to be the design of recursive function? If I have to say, if I have to make up a function, let's say this is my function and it is receiving root. What is going to be the design? I have to write my base case. I have to do my own work and I have to return the answer. Return the answer, my own work and base case. This is the basic design of any recursive function, and we are going to be implementing the same thing for this tree. Let's see the algorithm for the same. Okay, so what the algorithm says, just simply call the recursive function for calculating height. That is the only problem. What is going to be the function body? As I said, this is going to be your base case. What is base case? Whenever you hit null, you have to return 0. We have concluded why. Then what is the next step? We have to make a recursive call for the height of left subtree, and then we have to make a recursive call for the height of right subtree. Once we receive the height of both, what do we have to do? We have to take the greater height out of 2. Once you have taken the greater height, what is going to be the current height? The greater height plus 1. Why 1? Because that is for us to include the node that we are calling from. Okay, and then as a final answer, what do we have to return? The current height that we have calculated here. Simple enough. So let's see the code for it. Okay, and here is a possible code for the same. So you are given this function. I have used, I could have, made this function recursive, but just for making it easier, what I've done is I have made another function. I've named it helper, and I have passed on root to it. Okay, and I've made that in global domain. That is why I'm not using self, if you're wondering. Okay, so again, this is my recursive function. I'm passing root through it. And what am I doing here? Simply, we have seen it twice. I'm returning 0 whenever I'm hitting null. This is how I'm making up my recursive calls. First of all, I've called the same function upon the left subtree, and I have called the same function upon the right subtree. And once I receive the answer of both, what do? I calculate my current height. How? Choosing the maximum of these values, the bigger of these values, and by adding 1 to it. Finally, I'm just going to return this answer. Correct? Let's talk a little about complexity. Okay, because even if we are considering only the bigger value, in the case of 4, 3, only 4, but even for calculating all of these values, like both of the heights of right subtree and left subtree, what are we actually doing? We are traveling each and every node, right? We are traveling every node once. Thus, whatsoever is the number of node n is going to be the complexity of this. So height will be found out in O(n) time complexity. All right, let's try running the code that we have. Okay, so here's the same code. Let's compile it. Fine, it is compiling. Running it against all the test cases. All right, so it is passing all the test cases. So I hope you have understood the problem, and do comment down below if you like the video. Thank you.